Can Mars support life? Have you ever imagined humans living on Mars? A harsh, red planet with a thin atmosphere, violent dust storms, and temperatures that can drop to -100 degrees Celsius. Yet, despite these challenges, scientists are continuously searching for ways to make Mars habitable. But can this planet truly support life? What would we need to survive there? Let's explore these questions together. Mars has an extremely thin atmosphere, only about 1% of Earth's atmospheric pressure. Its composition is primarily carbon dioxide, CO, making up around 95%, while oxygen, the essential element for human life, is almost non-existent, at just 0.13%. This means that without life-supporting equipment, humans would suffocate almost instantly when exposed to the Martian environment. Furthermore, the low atmospheric pressure makes it impossible for liquid water to remain stable on the surface for long. If water existed on Mars, it would quickly evaporate or freeze instantly. This presents a major challenge in finding and utilizing water, a crucial resource for survival. Additionally, because of its thin atmosphere, Mars cannot retain heat from the sun. While daytime temperatures at the equator can reach a relatively mild 20 degrees Celsius, nighttime temperatures can plummet to -100 degrees Celsius. This extreme temperature fluctuation poses a significant challenge for any living organism attempting to survive on Mars. Beyond that, Mars' thin atmosphere also fails to protect the planet from harmful radiation from the sun and deep space. Unlike Earth, which has an ozone layer and a strong magnetic field to shield us from cosmic rays, Mars exposes any potential settlers to dangerous levels of radiation. This increased exposure can damage cells and significantly raise the risk of cancer. In summary, Mars' thin atmosphere is one of the biggest obstacles to sustaining life. For humans to survive, we would need artificial pressure domes, oxygen generation technology from carbon dioxide, and radiation shielding. Conquering Mars is not impossible, but it remains a formidable challenge. If you think winters on Earth are cold, imagine a place where the average temperature is around -63 degrees Celsius. And on the coldest nights, it can drop below -125 degrees Celsius. This is the reality of Mars' harsh climate, one of the greatest challenges for any life form trying to exist there. Mars is farther from the Sun than Earth, but distance is not the only issue. Its extremely thin atmosphere cannot retain the Sun's heat, causing temperatures to plummet rapidly once the Sun sets. While Earth has a greenhouse effect that stabilizes temperatures, Mars lacks a thick enough atmosphere to trap warmth effectively. Near the Martian equator, daytime temperatures can reach around 20 degrees Celsius, which seems relatively comfortable. However, as night falls, temperatures can drop to -73 degrees Celsius or lower. At the planet's poles, winter temperatures can plunge as low as -143 degrees Celsius, cold enough to freeze carbon dioxide out of the air, forming massive dry ice caps. With such extreme cold, liquid water, a necessity for life, cannot exist for long on the surface. Even if humans bring heating equipment, maintaining body temperature remains a major challenge. Protective suits and heating systems must operate continuously, not just to keep people warm but also to prevent machinery and electronics from freezing. This frigid environment makes it nearly impossible for complex life forms such as humans, animals, or plants to develop naturally on Mars. While some extremophiles, microorganisms adapted to extreme conditions, might survive, humans would require advanced technology, heated habitats, and efficient insulation to endure the cold Martian climate. The scarcity of liquid water? Water is the foundation of life. On Earth, every living organism, from microscopic bacteria to humans, depends on water for essential biological functions. However, on Mars, liquid water is an incredibly scarce resource, posing a major challenge for any plans to establish a human settlement on the red planet. Does water exist on Mars? The answer is yes, but not in the way we might hope. Exploration missions like Curiosity and Perseverance have discovered evidence of frozen water beneath the Martian surface, particularly near the polar regions. Erosion patterns on the terrain and the presence of minerals that once interacted with water suggest that Mars had rivers, lakes, and even oceans billions of years ago. However, due to the planet's thin atmosphere and low pressure, Liquid water cannot persist on the surface today, it either evaporates quickly or freezes instantly. Salty water and fragile hope. Recent studies suggest that liquid brine may exist on Mars during the summer. Especially in deep trenches or areas containing perchlorate salts, compounds that lower the freezing point of water. However, the amount of liquid water is minimal, insufficient to sustain a complex ecosystem. Moreover, this brine could contain toxic chemicals, making it unsuitable for immediate human use. Implications for humans. If humans want to live on Mars, finding and extracting water will be one of the top priorities. Scientists are researching methods to extract water from underground ice or from atmospheric vapor in Mars' thin atmosphere. Filtration and recycling systems will also play a crucial role. Much like how the International Space Station, ISS, recycles urine and moisture for reuse. A conquerable future? The lack of liquid water is a major challenge, but not an insurmountable one. With advanced technology, humans could extract water from ice or even produce it through chemical reactions using Martian soil and atmospheric gases. However, until an efficient method is developed, Mars will remain a dry and harsh world, requiring creativity and resilience to conquer. The invisible yet deadly threat, cosmic radiation. When discussing life on Mars, we're not just facing extreme cold or water scarcity. We must also confront an invisible but extremely dangerous enemy, cosmic radiation. On Earth, our strong magnetic field and thick atmosphere protect us from lethal space radiation. Mars, however, is completely exposed to high-energy radiation from the Sun and deep space. Why does Mars have high radiation levels? There are two main reasons why the Martian surface is exposed to cosmic radiation. Lack of a protective magnetic field. Earth has a strong magnetic field that acts as a massive shield, deflecting dangerous radiation from the Sun and deep space. Mars once had a strong magnetic field, but as its core cooled and lost the geological activity needed to sustain it, the magnetic field disappeared. As a result, the red planet is vulnerable to direct radiation exposure. Extremely thin atmosphere. Earth's thick atmosphere absorbs and disperses much of the incoming radiation. In contrast, Mars' atmosphere is only about 1% as dense as Earth's, providing little protection against ultraviolet rays, X-rays, and high-energy particles from the Sun and space. How does radiation affect humans and life? If humans are exposed to Martian radiation for extended periods without protection, they could experience DNA damage, increasing the risk of cancer, weakened immune system, making the body more susceptible to diseases, neurological damage, potentially leading to memory loss and cognitive decline, cardiovascular issues, increasing the risk of strokes and heart disease. Estimates suggest that spending 1 year on Mars could expose a person to 250 times the average radiation dose received on Earth, equivalent to undergoing 6.000 chest X-rays. Solutions for human survival. To live on Mars long-term, humans must find ways to protect themselves from radiation. Some potential solutions include building underground shelters. Settlements could be constructed inside natural caves or buried beneath Martian soil and rocks to reduce radiation exposure. Using radiation-resistant materials, scientists are developing special materials that can absorb radiation, such as polyethylene or water-based compounds. Creating an artificial magnetic shield. Some researchers propose building an artificial magnetic field around Martian settlements to protect humans, similar to Earth's natural defense. Living on Mars, a dream or a challenge? Cosmic radiation is one of the biggest obstacles to sustaining life on Mars. However, with advancements in science and technology, we may eventually develop effective protective measures, bringing us closer to the dream of conquering the red planet. But before that becomes reality, humanity still has many complex challenges to solve in order to survive in such a hostile environment. Food and energy, the next great challenge. If humans wish to settle on Mars, one of the biggest hurdles beyond radiation and extreme cold is securing food and energy sources to sustain life. Unlike Earth, Mars has no fertile fields, abundant rivers, or diverse ecosystems. Instead, it presents a barren landscape where the soil is unsuitable for farming, and natural energy sources are scarce. Martian soil, toxic and nutrient deficient. The surface of Mars is covered by a layer of dust and soil known as regolith, which has a chemical composition vastly different from Earth's soil. Some of the biggest issues with Martian soil include presence of perchlorate compounds. Studies show that Martian soil contains perchlorates, ClO, at concentrations ranging from 0.5% to 1%. This compound is highly toxic to humans if inhaled or ingested through food, as it can impair thyroid function and affect the nervous system. Lack of essential nutrients. Martian soil does not contain sufficient nitrogen, phosphorus, or other vital micronutrients needed for plants to thrive as they do on Earth. Poor water retention. Due to Mars' thin atmosphere and extremely low humidity, its soil cannot retain water well, making it difficult for plants to grow without artificial intervention. Food sources on Mars. How to survive. For long-term settlement on Mars, humans cannot rely on food supplies from Earth but must find ways to grow or produce food locally. Some possible solutions include agriculture in controlled environments. Scientists are exploring the construction of enclosed greenhouses that can maintain optimal temperature, pressure, and humidity for plant growth. Using bacteria and algae. Certain bacteria can help transform toxic Martian soil into a more nutrient-rich medium. Additionally, algae and cyanobacteria could be used to generate oxygen and provide a sustainable food source in closed-loop systems. Hydroponic and aeroponic farming. Growing plants in nutrient-rich water solutions, hydroponics, or in an air-based environment with misted nutrients, aeroponics, are promising methods for cultivating crops on Mars without soil. Energy shortages, no sun, no life. Beyond food, another crucial factor for survival on Mars is energy. On Earth, we rely on sunlight, fossil fuels, and renewable energy sources. But on Mars, all these options are more challenging. Weaker sunlight. Due to Mars being farther from the Sun, it receives only about 44% of the sunlight that Earth does, making solar power less effective. Frequent dust storms. Massive dust storms on Mars can last for months, covering the entire planet and reducing solar panel efficiency to nearly 0%. No fossil fuels. Unlike Earth, Mars lacks coal, oil, and natural gas, meaning no traditional fuel sources are available. Low temperatures hinder water-based energy. Hydroelectric power is not an option, as liquid water is nearly non-existent on the planet's surface. Solutions for the energy crisis. For humans to survive on Mars, a stable and sustainable energy source is necessary. Some potential solutions being explored include compact nuclear reactors. NASA has developed the kilopower nuclear reactor, capable of generating 10 kilowatts of electricity, enough to sustain a small Martian outpost. Wind energy. While Mars' atmosphere is thin, the strong winds during dust storms might still generate small amounts of usable electricity, producing fuel from the atmosphere. Some studies suggest using Mars' carbon dioxide-rich atmosphere to manufacture fuel, providing energy for human activities. Life on Mars, a tough but possible journey. Nutrient shortages and energy scarcity are among the biggest obstacles to sustaining life on Mars. However, with advancements in science and technology, humanity may develop new methods to transform this harsh environment into a livable one. Although many challenges remain, solving food and energy issues could bring us closer to making a Martian colony a reality in the future. Mars, once a wet world? Today, Mars is a cold, arid planet with a thin atmosphere and a dusty red surface. However, scientific research has provided strong evidence that vast amounts of water once flowed across its surface. Rivers, lakes, and even massive oceans may have existed billions of years ago, raising the critical question: did Mars once harbor life? Evidence of liquid water on Mars. For decades, NASA and ESA probes have sent back crucial data confirming the past presence of water. Ancient river channels. Orbital images reveal valleys and channels resembling ancient river systems, indicating that water once flowed across the surface. Lake sediments. The Curiosity rover has discovered clay and minerals formed in water, suggesting that a lake once existed in Gale Crater. Traces of an ancient ocean. Studies from the Mars Reconnaissance Orbiter (MRO) indicate that Mars' northern polar region might have once been covered by an ocean spanning millions of square kilometers. Hydrated minerals. Evidence of water on Mars. The presence of minerals such as hematite, goethite, and opal, which only form in wet environments, is also strong evidence of past water on Mars. How did Mars lose its water? If liquid water once existed on Mars, what happened to it? Why has the planet become so dry today? Scientists believe that the main reason is the weakening of Mars' magnetic field. Loss of protective magnetic field. Around 3.7 billion years ago, Mars' magnetic field almost completely disappeared, causing the planet's atmosphere to thin and water to evaporate into space. Drastic drop in atmospheric pressure. With its current atmospheric pressure only 0.6% that of Earth. Liquid water cannot exist for long on the surface. It would either instantly evaporate or freeze. Destructive solar radiation. Without a protective magnetic field, the solar wind stripped away most of Mars' atmosphere, pushing water vapor into space. The possibility of past life on Mars. If Mars once had water, could microbial life have existed there? Scientists believe. Ideal conditions. Over 3 billion years ago, Mars had a warmer climate, a thicker atmosphere, and abundant liquid water, all favorable conditions for microbial life. Chemical signs. Some collected mineral samples contain organic molecules, essential components of life. Could life still exist today? Some scientists suggest that while Mars' surface is currently inhospitable, microorganisms might still survive beneath ice layers or in underground caves. Searching for signs of life on Mars. The search for life on Mars is being carried out by exploration robots such as Perseverance and Curiosity. These probes are analyzing rock and soil samples to look for biosignatures, chemicals or structures that indicate past microbial life. Evidence of underground water. If water exists beneath the surface, microbial life might still persist. Soil samples that may contain ancient bacteria. Some future missions aim to bring Martian soil samples back to Earth for more detailed analysis. The future of water exploration on Mars. Although water no longer exists on the surface, underground ice deposits and traces of briny water could be key to future exploration missions. If humans want to settle on Mars, extracting water from underground ice will be crucial for drinking water and oxygen production. Water on Mars is not just evidence of the planet's turbulent past but also a critical clue in the search for extraterrestrial life. If Mars once had water and life, it suggests that life may be more common in the universe than we previously thought. Could life survive on Mars today? While Mars is currently a harsh, dry, and frigid planet, that does not necessarily mean life cannot exist there. Studies of microorganisms on Earth have shown that some species can survive extreme conditions, even similar to those on Mars. This raises an important question. Could bacteria survive on the red planet? Organisms that could adapt to Martian conditions. On Earth, several types of microorganisms can survive in extreme environments. Radiation-resistant bacteria, Deinococcus radiodurans, known as the superbacterium. It can survive intense cosmic radiation, even higher than radiation levels on Mars. Cold-loving microbes, psychrophiles. Some bacteria can endure extreme cold, like those found in Antarctica's permafrost or deep ocean trenches. Anaerobic bacteria, anaerobes. These microorganisms can live without oxygen, making them well suited for Mars' carbon dioxide-rich atmosphere. Salt-loving organisms, halophils, found in extremely salty lakes on Earth. They could potentially withstand the briny water that may exist on Mars. Tardigrades, water bears. These microscopic creatures can endure a vacuum, freezing temperatures, radiation, and even outer space environments. Evidence supporting the possibility of life on Mars. Experiments simulating Martian conditions have shown that some microorganisms can survive. Space exposure tests. Certain bacteria placed outside the International Space Station, ISS, for months survived, proving that microbes can withstand cosmic radiation similar to Mars. Experiments in the Atacama Desert, one of Earth's driest places. The Atacama Desert closely resembles Mars' environment. Yet, scientists have still discovered microbes living deep in the soil. Methane detection on Mars. The Curiosity rover has measured seasonal variations in methane levels. On Earth, methane is mostly produced by bacteria, increasing the possibility that microbial life could exist beneath Mars' surface. Microorganisms and the search for extraterrestrial life. If bacteria can survive on Mars, it opens up the possibility of extraterrestrial life. Scientists are focusing on areas that may support life, such as subsurface ice layers. If liquid water exists underground, anaerobic bacteria could be living beneath the surface. Seasonal saltwater flows. Some studies suggest that briny water may temporarily exist on Mars' surface during the summer. If true, this could be a potential habitat for halophilic bacteria. Martian caves or crevices on the surface could provide shelter from solar radiation, allowing microorganisms to survive. Microorganisms and the future of humans on Mars. If humans aim to settle on Mars, bacteria will play a crucial role. Oxygen production. Certain bacteria can be used to convert carbon dioxide into oxygen. Soil enhancement. Microorganisms could help improve Martian soil, making it more suitable for plant growth. Food and energy production. Some bacteria can be used to produce nutrients and biofuels. Bacteria may hold the key to understanding extraterrestrial life and could also lay the foundation for human survival on Mars in the future. Evidence of ice and groundwater on Mars. Despite Mars' dry and frigid surface, scientists have found evidence suggesting that water may exist in the form of underground ice or briny water. If true, this could increase the possibility of microbial life existing beneath the surface, where conditions are more stable and less exposed to solar radiation. Mars exploration missions like Mars Odyssey, Mars Express, and Curiosity have detected multiple signs of subsurface ice. Polar ice caps. Data from ESA's Mars Express shows thick ice layers at Mars' north and south poles, similar to Earth's polar ice caps. Radar detection of liquid water. The Mars Express spacecraft, using its MARSIS ground-penetrating radar, discovered a 20 km wide liquid water lake beneath the south polar ice cap, likely sustained by high salt concentrations. Seasonal saltwater flow patterns. NASA has observed dark streaks appearing on Martian slopes in the summer, believed to result from briny water flowing before evaporating. Stable subsurface conditions, a refuge for life? On the Martian surface, cosmic radiation and extreme temperatures make survival difficult. However, beneath the rocky layers, shielded from the harsh environment, microorganisms might persist, similar to lifeforms found in Earth's permafrost. Higher underground pressure allows liquid water to remain stable for longer, more consistent temperatures compared to the extreme fluctuations on the surface. Briny water could sustain bacterial life, much like halophils on Earth. The future. Could Mars support life? The discovery and extraction of subsurface ice could be a groundbreaking step for Mars' future. Supporting human life. Water can be used for drinking, oxygen production, and fuel generation, by splitting water into hydrogen and oxygen. Water for farming. If underground water is accessible, it could help create closed-loop biological systems, enabling long-term survival on Mars. Searching for extraterrestrial life. If bacteria can exist beneath the Martian ice, it would be one of humanity's most significant scientific discoveries. Could life exist beneath Mars ice? The search for microbes beneath Mars ice will be a top priority for future missions. Rovers like Perseverance and upcoming probes will drill deeper into the surface to look for biosignatures. If evidence of microbial life is found, it would confirm that life can exist beyond Earth, opening a new chapter in humanity's exploration of the universe. For decades, scientists have asked, did Mars ever host life? Or does it still? While definitive proof remains elusive, NASA and ESA missions continue to search for ancient bacterial remnants or subsurface microbes. If microbial life exists, it could be hidden deep within the planet's crust, protected from cosmic radiation and harsh environmental conditions. What are current missions searching for? Perseverance rover, NASA's key mission, landing in Jezero crater in 2021. Perseverance is tasked with searching for signs of ancient microbial life. Jezero was once a lake billions of years ago and could have supported bacterial ecosystems. The rover's instruments are drilling into the surface to collect rock and soil samples, hoping to find organic compounds, key indicators of life. Using spectrometers to analyze minerals and determine whether they contain compounds formed by biological processes. NASA plans to bring these soil samples back to Earth within the next decade for more detailed analysis. ESA's ExoMars rover, drilling deep into Mars. Europe is also racing against time in the search for life on Mars. The European Space Agency's ESA ExoMars mission, featuring the Rosalind Franklin rover, is set to drill up to 2 meters beneath the Martian surface. This unprecedented effort aims to find bacteria that may have survived within protective layers of rock, shielded from radiation and freezing temperatures. ExoMars objectives: search for complex organic molecules, which could be potential byproducts of life. Detect habitable environments, such as water-retaining minerals or traces of methane gas, a key indicator of biological activity. Methane on Mars, a clue to life? One of the most intriguing discoveries in recent years is the detection of methane in Mars' atmosphere. On Earth, most methane originates from living organisms, bacteria, or geological processes involving water. This raises the question: could methane-producing microbes exist on Mars? ESA's Mars Express orbiter and NASA's Curiosity rover have both detected seasonal fluctuations of methane levels. If the methane has a biological origin, it could indicate the presence of methanogenic bacteria living underground, similar to those found on Earth in oxygen-deprived environments. The future of the search. What happens if we find life? If we one day discover traces of bacteria on Mars, it would mark a historic milestone, proving that life can exist beyond Earth, even if no clear evidence is found yet. Each new discovery deepens our understanding of the red planet and whether it could one day become a second home for humanity. Terraforming Mars, turning the red planet green. For centuries, humans have dreamed of making Mars habitable, a place where we could breathe without spacesuits, grow crops in a mild climate, and walk under a blue sky. However, today's Mars is far too hostile, with a thin atmosphere, freezing temperatures, and deadly radiation. This has led to the concept of terraforming, the process of modifying a planet's environment to make it more Earth-like. Terraforming. Ideas for creating a new Mars. Warming Mars with the greenhouse effect. One of the simplest ways to terraform Mars is to increase the global temperature. Melting subsurface ice and releasing carbon dioxide into the atmosphere to create a natural greenhouse effect. Some proposed methods include giant space mirrors to reflect sunlight onto the planet's surface, releasing greenhouse gases like CFCs to trap heat for longer periods, detonating carbon dioxide ice deposits at the Martian South Pole to release stored carbon dioxide, increasing pressure and retaining heat. If successful, this could raise Mars' average temperature, allowing liquid water to exist, a key factor for life. Building a thicker atmosphere. Currently, Mars' atmospheric pressure is only 1% of Earth's, making it impossible for humans to breathe or for liquid water to remain stable. To fix this, scientists are exploring ways to use extremophile bacteria, like cyanobacteria, to convert carbon dioxide into oxygen. Much like how plants on Earth produce oxygen through photosynthesis. Extract polar ice resources and use solar energy to split hydrogen oxide into oxygen and hydrogen. Employ geoengineering techniques to trigger chemical reactions that transform carbon dioxide into gases beneficial to humans. Although this process could take thousands of years, if successful, Mars could have a thick enough atmosphere for humans to live without protective suits. Restoring water to the surface. Billions of years ago, liquid water existed on Mars. But today, most of it is either frozen or has escaped into space. Some proposed solutions to bring water back include mining subsurface ice, melting it into liquid reservoirs and artificial lakes, building massive greenhouses to create warm environments capable of sustaining liquid water, using chemical extraction techniques to capture water vapor from the atmosphere, potentially leading to artificial rainfall. With enough water, Mars could support life, vegetation, and even human settlements. Terraforming. From science fiction to reality? Although terraforming Mars is an exciting concept, current technology is far from making it a reality. Transforming a cold, barren, and airless world into a habitable planet could take centuries or longer. However, every study and every mission brings us one step closer to making Mars a potential second home for humanity. Will future generations witness a green Mars? For centuries, humans have dreamed of conquering new frontiers. And now, Mars is the next destination. With the ambition of making humanity a multi-planetary species, space agencies like NASA, ESA, and especially Elon Musk's SpaceX are dedicating enormous efforts to researching how to establish settlements on the Red Planet. But can we truly live there? And what challenges await? Challenges of building a settlement on Mars. Harsh climate. Mars is colder than Antarctica. With an average temperature of around -63 degrees Celsius, -81 degrees Fahrenheit, and nighttime lows reaching -125 degrees Celsius, -193 degrees Fahrenheit. This means that any settlement must have insulation systems and stable temperature regulation. Lack of oxygen and low atmospheric pressure. Mars' atmosphere consists of 95% carbon dioxide, with almost no oxygen, and the pressure is so low that humans cannot breathe without life support. Therefore, living stations must have oxygen production systems, utilizing technologies like MOXIE, Mars Oxygen in Situ Resource Utilization Experiment, to extract oxygen from carbon dioxide. Maintain artificial pressure within habitats, similar to the International Space Station, ISS. Dangerous space radiation. Without an ozone layer or a magnetic field for protection, Mars experiences radiation levels 50 times higher than Earth due to solar and cosmic rays. Prolonged exposure significantly increases the risk of cancer. Thus, settlements may be built underground or shielded with Martian soil and rock. Use radiation shielding technologies, such as magnetic materials or water domes. Water and food, the key to survival. Mars has no stable sources of liquid water on the surface, so settlers must extract and melt underground ice for filtration and use. Recycle water, just like astronauts do on the ISS. Generate water through chemical reactions, such as combining hydrogen and oxygen. Food supply is also a major issue. Transporting food from Earth is not a sustainable solution, so humans will need to develop self-sustaining agriculture in artificial environments, similar to what was depicted in The Martian, 2015. Mars colonization projects. Who will take us there? SpaceX and the goal of sending 1 million people to Mars. Elon Musk and SpaceX have set an ambitious goal: sending humans to Mars within the next few decades. With the Starship spacecraft, SpaceX hopes to transport hundreds of people and large amounts of cargo per trip, gradually building infrastructure for the first permanent settlement. NASA and the Artemis program. Although currently focused on the Moon, NASA is also planning a crewed Mars mission in the 2030s. They are developing off-Earth survival technologies, including oxygen production, water extraction, and research on human health during long-term space travel. Private and international projects. Besides SpaceX and NASA, several other organizations are also aiming for Mars. The Mars One project, although it failed, it introduced many fascinating ideas. ESA and Roscosmos with their research on extraterrestrial habitats. China is accelerating its Mars program with the Tianwen-1 spacecraft. When will humans be able to live on Mars? Currently, there are still many technological, medical, psychological, and economic challenges to safely sending humans to Mars and establishing a self-sustaining colony. However, with rapid advancements in technology, experts predict that within the next 50 to 100 years, humans may be able to live on Mars in a sustainable way. Would you be willing to be one of the first Martian settlers? Mars is no longer just a distant dream but a realistic goal for humanity. Despite the many challenges ahead, advancements in science and technology bring us closer to the day when humans will set foot on the Red Planet and build a new life. What do you think about this future? Leave a comment. Share this video if you find it interesting. And don't forget to like and support the channel. Thanks for watching.